Hi guys, welcome to my first YouTube tutorial. In this video, I want to talk about MP1 Paper D from MadAsMaths, which covers the AS Maths pure concepts. So let's dive in to some questions. So the first one is to evaluate the indicial expression, giving the answer in exact simplified fractions. So for the first part, it's really simple, where you just have to write down 4s and 8s as powers of 2. Okay, so let's jot that down. Okay, so 4 can be written as 2 squared times 2 squared 5 over 2 plus 2 to the power of 3 minus 1/3. Now that could be further simplified into 2 squared times 2 to the power of 5 plus 2 to the power of minus 1. Now that can also be written as 2 to the power of 7 plus 1 over 2. And now I'm going to go ahead and multiply the numerators together. So 2 to the power of 7 times 2 plus 1 and over 2. So that leads us to 256 plus 1 over 2, which is 257 over 2. So that's basically it for the first part. Now part B says simplify fully the following expression. Now that's got a power of 4 outside, so let's expand that. So that will be 2 to the power of 4 P4 Q8 times 5P Q to the power of 6 over 2 as it's square rooted. Now that becomes 16 P4 Q8 times by 5P Q3, and that gives us 80 P5 Q11, and that's it. So that's part B done. Now question number 2, show that the quadratic equation has 2 distinct roots, real roots, for some constant k except for one value. So now for 2 distinct roots, we know b squared minus 4ac is greater than 0. Now, for this one, I'm just going to rearrange the equation first so that the 1 appears on the left-hand side. And then I'm going to apply b squared minus 4ac, which is the discriminant. So that becomes 2k squared minus 4 times k plus 1, k minus 1. Okay, now I'm going to just simply expand. So 4k squared minus 4 times k squared minus 1, which is just the difference of 2 squares. So further expansion will lead me to this, and then that's just for greater than 0. Simple. So now we have to think, though, for what value wouldn't it be true? So if you think about this being true, let's think about for what value of k is it going to work. So for k equals, now I tried this, and k equals minus 1 will give me, when I input that value into my expression, will give me something like, let's say minus 2x, minus 2 equals 0. And that simplifies to x equals minus 1. So that's got one real value only instead of 2. Okay, so that's k equals minus 1. Now for question number 3, we are given a curve. And for this, we have to sketch, including the coordinates of its vertex and the coordinate axes. So now bear in mind there's a negative, and a negative quadratic or x squared graph will look slightly different to our usual graph, and that's just an upside down curve. So now let's first of all find out what our coordinate axes are. So on the x-axis, when y equals 0, I'm going to plug that into my equation. So 4 minus x times x plus 3 equals 0, which gives me x equals minus 3 and 4. Similarly, on the y-axis, I've got x equals 0. So y equals 4 minus 0 times 0 plus 3, and that gives me 12. So those are the 2 points, okay, or rather 3 points, and I'm going to go ahead and plot them following the shape of my curve, which is an upside down U. All right, so let's draw that out first. So I've got my x and y axis, and my coordinates are minus 3, 0 and 4, 0, and then on the y-axis it's 0, 12, and let's plot that around something like this. Now, yeah, that'll do. Now let's think about the midpoint on the x-axis. Okay, so that's just the line of symmetry. So if I drew that, the average between 4 and minus 3 is just half. Okay, and when I pop that into my equation, the main equation, it would just be half and 49 over 4, okay, on the y-axis. So that's it. That's my line of symmetry, which gives me the maximum turning point. Now for part B, I've got y equals f kx. So coordinates are 1, 0. Now I'm just going to pop that into my main equation. Okay, so 4 minus kx and kx plus 3. So 1, 0 helps me out further, and I'm just going to pop them into my equation, and k turns out to be 4 and minus 3, and that's about it. Now for question number 4, I'm given a curve with a line, okay, and P is a point where x equals 0, and I need to find the equation of the line L. So let's figure out what the y coordinate of P is first. All right, so at P, y is simply equal to the square root of 4, which is equal to just 2 because x is greater than or equal to 0. And the gradient function is just differentiation, which is half x to the power of minus a half. And that can be simplified like so, and popping in the value of x as 4 will give me 1 over 4, or a quarter. Now I've got my gradient and my y value, so I can just use y minus 2 equals a quarter x minus 4, which is the equation of the straight line. Now I'm going to further simplify it slightly, and it would give me y equals a quarter x plus 1. All right, so that's part A done. Now for part B, I have to figure out the finite region R, and for this, I really need to grasp concepts with integration. So I've got my main shape. Now that, if I just highlight that over with a triangle first, so got to find the area of the triangle, and for that I need that point on the x-axis, followed by the area of the curve under the curve, which is integration, definite integration. All right, so let's put this over. So I have to take away, so I've got my triangle, right? So that's the main section. 4 and point P is 4, 2, and I need that point, okay, on the x-axis. So I have to take away the area of the curve, okay, from this area of the triangle. Now that point is 4 on the x-axis, and that represents just P. All right, so now let's find out what that point on the x-axis is when y equals 0. And if I just pop that into the equation of the line of L, I would get x equals minus 4. And therefore the area is half times 2 times 8, right? That's just basically the distance between, and that gives me 8 units squared. Now let's integrate for the area of the curve between 0 to 4. Right, so remember to add 1 to the power, which is x to the power of 1 plus half over the same. And then that is obviously integrated between 4 to 0, and that turns out to be 2/3 x to the power of 3 over 2. And let's pop in the limit. So that will be 2/3. 4 to the power of 3 over 2 minus 2/3 times 0. Okay, and that gives me 16 over 3. All right, so therefore the required area, which I need, is the area of the triangle, which is 8 units squared, minus 16 over 3. And 8 times 3 is 24, so that gives me 8 over 3 units squared. Okay, so let's pop that over here. And that's pretty much it for this particular part. So that's easy peasy. All right, let's look into question number 5, which is expansion of brackets. Now, I've got 2 brackets here, and I'm going to need binomial expansion formula. All right, so let's pop it somewhere over here, let's say. And when I have to deal with the brackets, I am going to take my first one and expand it. All right, so let's do that first. And that will give me 1 plus 4x squared minus 4x. And the other one uses, as I said, binomial expansion. So here's a formula right up there on the side. Now expand it, and 2 to the power of 4 plus 4c1, 2 cubed times by kx, plus 4c2, 2 squared, kx whole squared. Make sure you use brackets. Okay, so that just goes on. Now let's simplify it into 16 plus 32 kx plus 24 k squared x squared, and so on. Now I need to put those 2 brackets together in order to multiply. So let's go ahead and do that. And now that's equal to my expression on the right hand side, which is a plus bx minus 104x squared, and so on. Now we need to think carefully over here. Expanding it all the way will not help. Let's expand it carefully. So first I'm going to expand with 1, and that will just give me the second bracket as it is. Okay, I only need x squared up to x squared terms. Now 4x squared times 16 gives me 64x squared, and then I don't need to do that. Okay, now of course I need to think about minus 4x, okay, term. So minus 4x times 16 will give me 64x, and then I have to do 4x or minus 4x with 32kx, which gives me minus 128kx squared, and so on. I'm ignoring the rest of the terms as I don't need them. Let's highlight the like terms. So I've got 32kx minus 64x. Okay, so that goes really well together, and I've got my x squared terms right here and just a constant. Okay, 16. So on the right hand side, if I compare the same, I'm gonna have the a with 16, and the x squared terms in red, I've highlighted that, which is minus 104x squared, and bx. Now a is 16, and with b, if I compare my coefficients of x, that's just equal to 32k minus 64. All right, and I've got my x squared coefficients, which is 104 equals 24k squared minus 128k plus 64. Now I'm going to go ahead and solve this as a quadratic equation by bringing in 104 onto the right hand side, factorizing it like so. And it's just really simple. Okay, you can pop it in the calculator as well, but I highly recommend you write it down like so. Okay, so k equals 7 over 3 and 3. Now I'm gonna, of course, find out the values of b. this is what the question is asking. So when k equals 7/3, b is equal to 32 times 7/3 minus 64, which gives me 32 over 3. And then for k equals 3, b is 32 times 3 minus 64, which is equal to 32. And that's it. So for question number 6 over here, an area is to be planted with eucalyptus tree after a large fire. The height is given by this function, which is exponential. T is the time in years. And we need to, for first part, find out the height of this a newly planted tree. So that's really simple, guys. All we have to do is simply plug in t as 0, okay, in the equation. So h equals 25 minus 24 e to the power of 0. Remember, that's 1, okay, and that leaves me with 1 meters of height. For the second part, find the height after 2 years. Okay, again, really simple. Pop it in, and boom, you will have your answer as 5.35 meters. Okay, now for third part, we have to calculate to the nearest integer the value of t when the height of a tree has reached 80% of its eventual height. Now that is a keyword. Eventual means t is tending to infinity, okay, and so we need to find that value of h first. So at t equals, well, infinity, h will be equal to just 25 meters because e to the power of infinity is just 0. You can try that in the calculator, a really large value of e. So 80% of 25 is 20 meters. And then let's put that in to our main function, okay, of height and time. So 20 equals 25 minus 24 e to the power of minus 0.1 t. And that just gives me minus 5 equals minus 24 e to that. Simplifying this a little bit further will give me 5 over 24. Natural logging both sides. That's easy, hopefully. And that gets rid of e. Okay, gets rid of e, I mean. And now I'm going to just pop it in my calculator, get it as minus 1.568 over minus 0.1. And that gives me t as 15.68 years, or, well, 16 years as whole number. That's it for this one. So let's talk about question number 7, which is a y function, and we need to figure out the range of x for which y is, well, an increasing function. Okay, so that is when dy over dx is greater than 0. So we just have to differentiate this. I'm going to rewrite this like so, and differentiate as normal, easy. 1/3 x to the power of 1/3 minus 1, and then minus 27 x to the power of minus 2. So I'm going to just tidy up. I like to keep positive powers whenever possible, and that is greater than 0. Now I'm just going to cross multiply here, and the numerators will become like so, and the denominator will be like that. I'm just going to get rid of it anyway, so just don't worry about expanding it. Now, for the numerator, I've gotten this far, okay? I'm just going to go ahead and add that over, okay? So 81x to the power of 2/3. Divide both the sides by x to the 2/3, and simplify it slightly, okay, with indices as 2 minus 2/3 greater than 81, which gives me 4/3 greater than 81, which gives me x as simply 27, as I have to take the fourth root and then cube my answer. Okay, now question number 8. Differentiate from first principles. Here's a formula, all right, just to jog up your memory, but it's going to be given. Now fx is 1 over x squared, and fx plus h is 1 over x plus h squared. Okay, now here I'm going to just put it in my formula. So lim h tends to 0, 1 over x plus h squared minus 1 over x squared over h, all over h, and that just gives me x squared minus x plus h squared over x plus h squared times x squared divided by h. Now, I can further simplify by expanding the second bracket. So lim h tends to 0, and x squared minus x squared plus h squared plus 2xh over the same. Okay, and that's just flipped over. Easy. Now, make sure you expand with a negative sign carefully, right? Because this is where most of you go wrong. So now I've done that. Okay, I'm going to carry on and simplify. And then I'm just going to take the h out, okay, or minus h out. Okay, so h plus 2x over the same. Now that helps me cancel out the h's. Okay, so h and h go to hell, and then that leaves me with h plus 2x, or rather, I need to have this further simplified as when h is now 0, f dash x is going to be 2x. Sorry guys, there has to be a negative sign there. So minus 2x over x squared times by x squared, which leaves me with minus 2 over x cubed. Simple. Question number 9. Here we have been given an x, or rather a third form equation, and we need to get it in terms of p root 2, the values of x. So simple, let's multiply everything by x. Okay, and I'm going to just take away 6 root 2x and then simplify using completing the square. Now remember how to complete the square. Okay, I'm not going to go over that just now, but you just have to have the coefficient of x and take away the square of that number. Now, adding 32, square rooting both the sides, that's really simple. That will give you 2 values of x. Now, for that, you're going to end up just keeping it in terms of surds. Please do not use a calculator here. So for the positive, when there's a positive, you're going to get 7 root 2. For the negative value of x, or rather for the negative, you'll get negative root 2. So your value of p is 7 and minus 1. And that's it for this question. Now, the next question is about graph, and we have been given a cubic function where it meets at 4 distinct points, the coordinate axis A, B, C, and D. One of the points are given to us, -3 and 0. So now here I need to figure out the coordinates of B, C, and D. Now because I'm given one of the roots, okay, that means that x plus 3, okay, is a factor of fx. Now that really helps me because I can go ahead and set up a long division and simply figure out what are my other roots. Okay, so I'm going to have x plus 3. Okay, so I need minus x squared there. Okay, and this will give me this. And I'm going to take away, in order to cancel out the first terms, 8x squared plus 17x minus 21. Now I need an 8x there, and so 8x squared plus 24x, and then I have to take away again, so that cancels it out, and that gives me simply 7x minus 21, or rather minus 7, okay, and that is all good, because that gives me 0. Okay, so x plus 3 and minus x squared plus 8x minus 7 will be equal to 0, or fx. Okay, so I'm gonna factorize here, and that will give me a plus 7 and minus 1, and that will equal 0, and therefore I get my extra roots, x equals 7 and 1. So those are my other coordinates on the x-axis. For the y-axis, x is 0. So pop it in to the main function, and you'll simply get minus 21 when you do so. And there you have it. So for question number 11, we've got 2ct minus 2c plus t minus 1. And we have to put it in two linear factors. Group them. Okay, so you're going to have 2c outside, which leaves you with t minus 1. And you've got nothing common, so t minus 1 again. Put them again together, 2c plus 1 and t minus 1. Now here we've got next part, which involves hence, okay, using therefore the previous part. So I'm going to just cheekily write that down. Okay, cos is c, tan is t, and the 1 obviously can be brought onto the left-hand side. So I can apply my results from the previous part, okay, like so. All right, so now here I've got two brackets, so cos theta will be equal to minus a half, and tan theta is 1. And so theta is cos inverse of minus a half, and tan inverse is of 1, which is 120 and 45 degrees for tan. Okay, so I prefer the quadrant diagram, so I'm going to do that. So, or the cast diagram. Okay, so ideally cos is positive in the first and the fourth, but because it's obtuse, it will be there and there. So 120 degrees. So I need that point there. So 360 minus 120 will give me the secondary value. And similarly for tan, I've got tan positive in the first and the third quadrant. So I just need to add 180 to 45 degrees, which gives me 225. So there you have your values of theta as 45 degrees, 120 degrees, 225, and 240 degrees. And that's that for this question. So question number 12 here. We've been given an equation of the line and the curve, like so. And we need to find out the coordinates of the points of intersection between L and C. So for this one, I'm going to have to solve them simultaneously, but first, let's go ahead and simplify the equation of L. Okay, so just getting it in two separate fractions, okay, and 1 plus x, 1 plus y over xy equals 1. Now for C, I've got xy as well, which is good news because I can always rearrange or always, pop it in. So 1 plus x plus y plus xy is equal to xy, okay, upon expansion. Now 1 plus y plus x, now you can either just replace the minus 2 here or just cancel them out, and you're going to get 1 plus x plus y equals minus 1. So that's your equation of the straight line. And for C, y equals minus 2 over x. Now, solving them simultaneously is easy. Pop the value of y into the equation of the line and solve for x. Okay, so that will give me a quadratic, and when I go and simplify that, I'm gonna end up factorizing as x plus 2 and x minus 1. So x is minus 2 or 1. Now put those into the equation of the curve to give you y values. So those are my two sets of intersection, minus 2, 1 and 1 comma minus 2. So there you have first part done. Okay, now let's look into the second one, which asks us to sketch the graphs of L and C in the same set of axes. So we know L is a straight line. Okay, so the second one is a reciprocal curve. C is a reciprocal graph. Okay, but obviously it's reflected. So let's put them down here. So y equals minus x minus 1. And C is, well, the curve is y equals minus 2 over x. So remember the reciprocal graph, but the reflection will be slightly different, as in it will look like this, okay, as it's reflected. Now, let's put equation of the line, or the line here, and we know that it would cross the y-axis at 0, minus 1, and we know the points of intersection with the curve as well. So there you have it, the two graphs in one, okay, the line and the curve. Now in this final question, number 13, we've been given a circle C1, which has the equation like so, and we need to find the coordinates, center and the radius. So that's really easy. I'm just gonna rearrange the equation in terms of x squared minus 10x plus y squared plus 4y equals 71, and just complete the square. And it will look something like this, which is really simple to be honest, and gives me x minus 5 squared plus y plus 2 squared equals 100. Okay, so that gives me the center as 5 comma minus 2 and the radius is 10. Now for another circle C2, which is centered at the point with coordinates minus 4 comma 10 and radius 5, we need to show that C1 and C2 touch each other. So let's first of all write down the equation of the circle C2, and that will be quite simply written like so. Now, if they touch each other, they must have perhaps the distance in common. So let's figure out what the distance between the two centers is and see whether we can match up to the radius. Okay, so the distance turns out to be 15, and so the circles do touch because the radius or radii of the two circles add up to 15, and so they would touch the edge of one another. Okay, I'm going to just write that down quite explicitly over here. So I hope that makes sense actually, because it could be quite tricky otherwise to get your head around, but feel free to draw this out if in doubt. Okay, now the next part is where we've got two circles which touch at point P, and the straight line L is common tangent of C1 and C2. So let's put this in a diagrammatic form. So I've got my circle, a smaller circle with the radius 5, and the other one is slightly bigger. Let's go ahead and just jot out some numbers. So the other one is 10, and the radius and the center is 5 comma minus 2. So the tangent is L, and we have got a common point P. So I'm gonna say P is x comma y. and it will satisfy the equation of one of the circles. I'll choose the second one, the bigger one. And the gradient can be very helpful. So m, okay, the gradient of the main line, the two centers, could be written as -2 minus 10 over 5 plus 4, which gives me -4 thirds. This will be the same for the gradient from p, 2.5 and -2. So here I have another equation in terms of x and y, and if I simplify this, all right, in terms of perhaps x or y to be the subject, I can simply put this in my the equation of the circle, one of the circles, and solve it simultaneously. So I'm going to go ahead and do that. I'm going to put this form into my equation of the circle, the bigger circle. So x minus 5 squared plus minus 4x plus 14 over 3 plus 2 squared equals 100. And it may seem tedious, but it's really, really simple if you combine the second fraction together with 2. Okay, so minus 4x plus 20 over 3 over 2 and equals to 100. Now expand the brackets, and I'm going to end up getting 400 over 9 minus 160x over 9 equals 100. Multiply everything by 9. So I'm going to get really large numbers, but that's okay because they can simplify. These numbers don't look that bad. And I'm going to put all the x's together, x squares together, and all my constants together, and use the calculator to get x as 11 and -1. Now, because the value of x that we should have has to be between -4 and 5, so x is therefore only -1. And from here, I've got my y coordinate of p as just using that equation. Okay, so -4 times by -1 plus 14 equals 3, once divided. So I've got -1,6. So for the final part of this question, I have to show that the equation of L is in that form. Now, that's really easy because I've got my coordinates of P. All I need to do is work out the tangent, the gradient of the tangent, which is the perpendicular bisector of what I worked out earlier. So y minus 6 equals 3/4. So that's y minus 6 equals 3/4 x plus 3/4. I'm going to multiply everything by 4, and that would give me 4y minus 27 equals 3x. And that's about it, guys. I hope you found this useful, and thank you so much for listening, and please like and subscribe for more such videos.